Last session we completed about our OSPF configuration. Now we're going to discuss about the netting, and tomorrow we'll configure the net. Okay, we'll do the practice of the netting by tomorrow. So what is the netting? Krishna, Lakshmi, Rajesh. So network address transfer is a very important concept for every network engineer. Okay. So as we guys knows, like the private IP cannot directly communicate with the public IP, and public IP cannot directly communicate with the private IP, right? Let's suppose I'm having one user here, 192.168.1.1, okay, with the internet, and we have a 18.8.8.8 server, public server, Google server. Just consider this as a Google server, okay. Now this user wanted to access establish the communication from here to there. So how the packet will come? Source IP 192.168.1.1, destination IP 8.8.8.8, correct. Packet will reach to uh, our next gateway router, and from router to it will reach to the internet. But internet will send in this device. The our request will come to this device, but this device will reply to that, and this time of replying 8.8.8 will become a source. Destination IP will become a 192.168.1.1. So in this kind of scenario, the public IP is dealing only with the public IP is dealing only with the public network is only dealing with the our what? Sorry, the public IP only will deal will with public network, not with the private network. So it will check the source IP. Source IP is a public network, fine, but the destination IP is a 192.168.1.1, and in the world the 192.168.1.1 series is completely a private IP. So private IP anyone can use in the world, right? We can, there is no restriction. But the public IP is a unique, like our Aadhaar card or vehicle number, right? So the public IP is completely dealing with the the public network is completely dealing with the public IP. They don't have rights on private IP to stop anyone to use this. Okay. So let's suppose this will come to this in public network, and this will check by the seeing the destination network, it will drop the packet. Okay. So by default, private IP cannot communicate with the public IP, and also the public IP cannot by default communicate with the private IP. So to avoid these issues, that INA has started this net. Okay, net. So network address translation, by using a network address translation, what we can do? Just a minute. By using a this network address translation, INA can do. Okay, let's suppose private IP, public IP. Okay, this is our server 8.8.8.8. This is our user 192.168.1.1 user connecting with the router to the public network. Okay, this is a public network. Consider this is in our server. Okay, so how the packet will come here? How they'll start the communicating? Again, the packet will come. Okay, again this private IP source IP will become 192.168.1.1. Destination IP will become our 8.8.8.8. The packet will generate and packet will reach to our router or firewall. Here there is a netting. We are using one IP 1.1.1.1, and here this is in a router. Okay, a router, not router. This is an internet. Okay, and this is a server, public server. Let me do it again quickly. This is a server. Okay, now this device wanted to come establish the session with the 8.8.8. In this kind, how the packet will generate? By the source IP 192.168.1.1, private no source IP and destination IP 8.8.8.8, packet generated, packet sent to the router. Let's suppose here network address transition has been configured. It should be a router, it should be a firewall, okay? It should be any netting device. So here we are having 1.1.1.1 IP and 1.1.1.2 is our gateway. Okay. So the packet will here packet will change. Source IP will become our 1.1.1.1. We just did a configuration with the pet address for petting we did here. Okay. Source IP will change here and the destination IP will be the same 8.8.8. It will reach to via internet, it will reach to the server. Server will check the request came from the 1.1.1.1. Okay, now the server will reply. Okay, server will reply. At that time source IP will become 8.8.8.8. Destination IP will become our 1.1.1.1. Packet will generate, packet will go to the internet will check source IP. Okay, fine. Destination IP is also public, fine. Send this packet to our next hop. Next will receive this packet, it will check their database. Okay, database, it will check the no, connection table, we can say this. It will check, the device will check their connection table. It will check source IP. There was one request went towards 1.1.1 by checking, by getting this 1.1. We made this 1.1 with the 1.1, then the request has been sent. It will check that the request is coming, and accordingly it will send to the public private IP. Okay, so netting is overall, we can say it is a breeze in between a static this private IP and the public IP. Okay, or we can say netting is the mediator between the private IP and public IP to establish the communication, right? Correct. Let's suppose one person is in, he knows Chinese, one person knows Hindi. Okay, but we required one person who knows both the language, even Chinese, even English. So if anyone in the communication for the communication exchange, the person should be there who knows both the language, right? So this is the role of this person is ruling by that netting. Okay, so network address transfer is a service which enable to map one IP address to the public IP address. Net, a feature which enable private IP address to communicate with the public IP address or vice versa. When we talk about IP address style, we have a three style: unicast, multicast, and the broadcast. Okay, clear? The same thing which you already discussed. This is also same thing. Okay, private IP address, we knows about this. Okay, private organization. So private IP, we don't have any restriction to any it is using by the private organizations. Why net required? Now assume that company is having a private IP line. These are also same thing. Okay, we just need to jump in the types of net. So net, static net, dynamic net, paired, and static or destination paired. Static net supported by the Fortigate, dynamic net not supported, paired supported by the Fortigate, static and paired or destination net supported by the Fortigate. Okay. So static net, we required one to one private IP 192.168.1.1. We need to map with one public IP. Let's suppose 1.1.1.1. We cannot use for other private IP this IP. Okay, this IP is permanently reserved for this 192.168.1.1 user. Whenever you wanted to access the internet, it should be mapped with the 1.1. Okay, but we cannot allow a multiple private user by using a single public IP, because this public IP is already mapped with this private IP. Think about it. Okay, so now what we are going to discuss, we are going to discuss about a dynamic net. In this dynamic net also we have a limited option. Like suppose we will use a pool of IP address. Okay, let's suppose we have a one public IP 1.1.1.1 to 1.1.1.4. So here 1 2 3 4, so total 4 IP we purchased from our ISP. So at the time only we can allow 192.168.1.1, 1.2, 1.3, 1.4. They can reach by using 1.1, 1.2, 1.3, and 1.4. But we have one more user 1.5. They cannot use this IP because this IP is already used. This request will be in queue. Once the existing request or existing query has been resolved. Okay, once the query has been resolved, then it will reply it. Okay, it will allow to 1.5 to access the internet by the available IP address. Clear? So these both are not used in the real time scenario. When you talk about when we talk about this is not allowing. Okay, just a minute, guys. So this is not in use. You can say this is not this both static net and the this dynamic net. Static net, dynamic net, we are not using. We are using the pet and static pet or destination net. So what is the pet? We have a one IP 1.1.1.1. Okay, 1.1.1.1. By using the port address translation, we have a range 0 to 65,535 is a port number. Okay, the well-known port number is around 1023 minus just around 64,000 user can access by using a single public IP address. 64,000, around 64,000 private users can access the internet by using a single public address. So how the communication will be possible here by using a single public IP address? Let's suppose I am having one user 192.168.1.1. It is mapped with the 1.1.1.1.1. Okay, so whenever the request will go, that this will add dynamically port number 44i. It is add the 2.1, no, 1.2, sorry, 1.2. It will also use 1.1.1, and it will check any dynamic port number. 1.3, it will check around. It will also map with the one same IP with the port number change, right? So and so on. This will be up to around 64,000 plus users can access by using this port number. Okay, by unique port number. So nowadays we are using this dynamic net. Sorry, not dynamic net. Paired only we are using. Okay, is it clear? So now static paired or destination net, we can say the destination net. Let's suppose I have a one server in my office which is connected in the switch. I am having one more server which is also connected in the switch, and I have an internet connectivity. And there is one public user. Okay, like you and me, we are accessing the YouTube, Facebook, right? So this is a YouTube. Consider this is in a Facebook. I hosted this YouTube in the port HTTP. The HTTP port number is a 40. I hosted this Facebook with the HTTPS. The port number is a 443. So my IP address is 1.1.1.1. Okay, I'll I'll configure here whenever anyone is trying to access, whenever anyone is hitting 1.1.1, 1.1.1.1 with the port number 80, like HTTP request will come. This server IP address is 192.168.1.10. So whenever just someone is trying to access 1.1.1 with the port number 80, hit it, request came to the gateway, it should be redirect with the 192.168.1.0. Whenever someone is hitting with 1.1.1.1 instead of 80, if someone is hitting this time 443, the request will come to the gateway will send to this interface, this router. So overall we can, what is my meaning, so by using a destination net we can allow a public user to access our private network. Okay, so we're using pet and destination net only. Clear? So static net is the same, one mapping. Dynamic net, okay, single or some public IP. That's it. So this is about the net and network address transition. That so net introduction has been done today itself, and tomorrow we will do our net introduction. Then tomorrow we will do the practice for this netting. Okay. Tomorrow we will do net and user authentication, and the day after tomorrow we can do side to side VPN introduction. Okay. See you guys. Any question? Krishna, Lakshmi,
Yes.
is it
No
clear?
one.
No worries.
Yeah. No question.
No.
Thank you guys. We will start by tomorrow. Okay.
Yes.